Hello, my name is Andy Corston-Petrie, and I'm a Senior Research Manager in BT Applied Research. I lead a team of researchers primarily concerned with the core of the mobile network, but also future 5G services and things like edge computing and network slicing. And I'm here to talk to you today about the story of 5G and some of the use cases that we've been exploring over the recent period. So first, a bit of a history lesson. How have we got here towards the era of 5G? Some of you will be able to spot your first mobile phone on this chart. For those of us that are a little older, it's a little too far to the left of the screen for comfort. But really, this chart tells the story of the evolution that we've seen in our lifetimes of mobile technology from the mid-80s. And the surprise and wonder element of being able to make mobile telephone calls on the go, through to the penetration of these types of devices into the public conscious and the mass market through simple screens and Blackberries and PDAs. And then really towards the middle there, we're seeing the advent of color screens and more flashy design into the handsets. And then, of course, the era of the smartphone with the launch of the iPhone, which was the game changer, the era of the app, being able to do so many more things on a single device in your pocket. As we move through those generations towards 4G, most of you will be familiar with looking at the symbol of 4G in the top of your device screen when you're out and about on various devices. But now we're entering the era of 5G. Some of you may even have 5G service on either your personal or your business devices. And we're really evolving the story now from being able to make communications on the go, but now, through the era of having internet connectivity, then having that reliance on Wi-Fi and cellular connectivity for so many aspects of our daily lives, through to a whole set of new applications and use cases that require wireless connectivity as an essential capability. And we really see the era of 5G as being a good decade here, where we're only really at the start, and that's how we've got to the story of 5G as we know it today. The vision of 5G is a converged network supporting all different types of services, and it's very useful to break down the types of services into normally three groups. We have enhanced mobile broadband, which really relies on a massive increase of data rate to your device to support things like interactive gaming, tactile internet, virtual reality, etc. Mission critical machine type comms, really that's connecting major industries, enterprise applications, health applications, transportation, robotics. And really those applications and devices and technology are going to require a scale of reliability and low latency that's not previously been possible on mobile networks. You never really would have considered putting these types of applications and services on previous generations of mobile capability. And this is one of the key new areas that 5G is really pushing into since its conception. And then finally, we have massive machine type comms, and this is really connecting everything to the network. This is the Internet of Things, which of course doesn't necessarily rely on 5G, but we really see as 5G as being an enabler for the next phase of IoT realization, whether it's logistics, tracking, smart agriculture, smart industry, smart energy. It's really that massive uptick in the number of connected devices in a local area. The target they talk about is 1 million devices per kilometre squared. Which is a massive increase on what's around today. And of course, the challenge there for the network is that those devices may have battery sensitivity. They may, every time a device wakes up and talks to the network, it's consuming battery. So there's all sorts of different considerations required for that type of use case. And really, these three different types of use case are going to stretch and stress the network in different ways, and that's what we're looking at now. And if you position these all on this type of triangle, which some of you may have seen before, the enhanced mobile broadband, as I said, is really all about the peak data rate to your device. The ultra reliable low latency communications, the mission critical communications, are really about that ultra low latency and high reliability. And the massive machine type communications are all about those the massive number of devices and things like battery life. And that's how we've got to think about 5G. It's a multi-service, multi-purpose network. And being able to do all of these things on a single deployed network is where some of the technology challenges actually lie. As 5G has started to evolve from the early days of release 15, where some initial use cases were envisaged, those early days were really about growing value and starting to look at some of the initial use cases. Release 16 then added standalone private networks, new low latency use cases, hybrid cloud, and starting to bring and grow bring new partners into the ecosystem, and again looking to push on and grow value with an enterprise mindset. And then release 17 really bringing on a whole set of new network capabilities, such as scalable network slices and dynamic service level configuration, really about pushing the bounds of what's possible with service differentiation on that single 5G network. Down the side, you can see there that really stretching our thinking in terms of what those 5G use cases might actually demand on the network, and looking to take those use cases into realistic environments where we can really stretch and stress the network and understand what these new services are going to require. Because this is a good thing to do for enterprises. This can lead to increased productivity, operational efficiency, increased margin, but at the same time may drive through that efficiency some cost reduction. There's health and safety benefits, say, for workplaces, and of course revenue growth, which is at the forefront of all this investment. Alongside 5G, there's this growing discussion about 5G private networks. There's several 5G networks, private networks already deployed. And we see this as one of the game changers, because this can allow us to deploy dedicated secure mobile networks for critical network operations. Sometimes a remote site may not have any other connectivity options, so you may need a private network to guarantee your coverage and reliability. For example, seaports, manufacturing sites, remote oil refineries, army bases, etc. But it also gives local control and customization to the network that you're actually using, in terms of being able to tailor your network behavior for your own use. And we can also fold in things like on-prem computing and edge computing, things like that. But of course, if you've got a private network, fundamentally that gives you control over your security, whether it's dedicated infrastructure or a security wrap that allows you to manage your own traffic flow, your users, your prioritization. And that starts to mean that we've got an end-to-end solution that we can take to enterprise type customers and talk about mission critical networking. We're really taking the mobile network away from just the public network and access to cloud applications, but really looking for that huge transformation there of taking the technology into new sectors and new industries. What I'd like to do over the next few minutes is talk to you a little bit about some of the use cases that we've been looking at. Our colleagues in enterprise have been doing a lot of work with Belfast Harbour, looking at supporting augmented reality for providing remote support for field engineers, for providing drone-based surveillance, connecting air quality sensors, and looking to explore things like remote crane operations. And these types of initiative and effectively creating like a real world test bed allow a much deeper, more realistic exploration of what the technology is actually capable of. Another example is one that's a little closer to home for myself and my colleagues, is connected ambulance. We actually demonstrated this on the Channel 5's The Gadget Show back in late 2019, which seems like a long time ago. And this is all about connecting a hospital to an ambulance using the power of the network. So you can see in the middle there that we're facilitating a huge next generation change in all the different modes of communication that can happen between a hospital consultant and a paramedic in the back of the ambulance. Not just voice and video, but where we can share ultrasound instrumentation details back to the hospital. We've got haptic communication, so the hospital consultant can use a joystick to send signals to the haptic glove that the paramedic is wearing in the picture there. And that's all running integrated into our network, actually using a technology called IMS, integrated with 5G. We built this in conjunction with our colleagues in King's College London and Ericsson, and using the network this way rather than just as a data connection gives us the benefit of thinking about the end-to-end security, the mobility management, the quality of service, reliability, etc. When we're connecting two different sites and two different sets of technologies together there. A little more there then on another use case where we're looking at augmented reality for remote operations. This one is about using controllers that you can see towards the middle of the picture there to control a robotic arm, as shown in the picture there, but also adding in again the immersive audio and video communication channels, the control and command signals that need to flow back and forward between the controller and the robotic arm, but also the haptic and force feedback from the arm's gripper to send signals back to the operator when the arm has actually picked something up. And again, this is a use case requires us to demonstrate and facilitate that the step change in bandwidth and latency and reliability if we were actually going to build real world services using this type of technology. This could be used in mining, in forestry, logistics, and autonomous shuttles as shown there. Also health potential applications and warehousing, and really anywhere where the operator is unable or perhaps for health and safety reasons desirable not to be in the same location as the action being carried out, means that that's a potential use case for this type of technology. Another example is autonomous drone control. This is a project we're working on with colleagues in a company called Unmanned Life, and we're looking at doing autonomous drone control for fleet coordination. We're adding in computer vision for AI-driven video analytics, and we're building the capabilities to be able to test this across 5G public or private networks, and adding in things like edge cloud compute to give that low latency and security. So we're looking at connecting our edge cloud platform at our BT labs over 5G to the drone swarm, and again facilitating a range of communication channels between the two endpoints. And that, again, along the bottom there, has got a range of use cases there: emergency response, surveillance, industrial automation, etc. And means, again, it's quite a rich environment for exploring this type of technology and its application in the real world. Maybe one final detailed example here is something we've been exploring. It's a little different, using holographic communications in real time. We're working on this in a project called 5G Edge XR with a range of partners, and we're looking at using again the high bandwidth uplink on our 5G network to connect a source camera feed or rendered display from one end, using in-network graphics processing units, GPUs, to display a new generation of immersive experiences to user devices, whether that's for entertainment, such as the boxing match you can see displayed in a sort of augmented reality tabletop display there. Holographic communications, perhaps for point-to-point communications into another generation of consumer devices, or for remote education, as shown there for remote dance classes where students or pupils would wear augmented reality glasses to participate in a dance class where their teacher was actually somewhere else, and we're working with colleagues at Dance East here in Suffolk to explore those opportunities. And again, this type of application needs high bandwidth, low latency, and high definition volumetric video in real time in order to bring those experiences to life. And there are a whole set of other use cases, whether it's industrial automation or anomaly detection using a video capture. 5G can bring all sorts of other capabilities to the market, to the exploration. Whether it's dedicated standalone mobile core, and again, that step change in secure and reliable private networks, on-prem customer edge, dedicated radio coverage, and again, we can bring high bandwidth, low latency, reliability to a wide range of use cases there. So just to sum up where we are, these are still a huge range of technology challenges that require our research, and we're actively working with partners and universities and all sorts of other industry bodies and standards organizations to explore this. I suppose it breaks down into a number of areas. We've got to look at coverage for indoor and rural. What is the economics of improving coverage? There's all sorts of technology innovation going there. Sustainability is a key driver for a lot of technology research that we do now in terms of energy consumption and dedicated use cases for energy use. We're very active in the convergence space, looking at how we bring the best of our network assets together for new user experiences in a cost-effective way, so across fixed, mobile, satellite, and all the while looking at things like network automation that kind of help with our business agility and cost reduction, and looking to explore new supply chain, new partnerships, and new ecosystems to help us bring some of these 5G use cases to reality. Thank you very much for listening.